In this video we're actually going to perform an inertia dyno test. We'll leave all the settings as default as in the previous videos. Including RPM, here it's set on RPM, but we can also test in speed mode, so kilometers or miles per hour. But as an engine dyno, it makes more sense in our example to use RPM. So we'll go to the dyno screen that we use for testing. Here we can see weather correction information that is being pulled in automatically from the weather station. You can manually enter that if you choose as well. Down here we have a row of dials that are basically showing what is coming into the dyno unit on the input channels. These are just hooked up to a simulator at the moment, so they'll be stationary during the test. Now, the key thing here are record settings. Record settings tell the software when to begin recording the data and when to end recording the data. That gives us a clean start and finish to our test data and prevents it wrapping back underneath. So in other words, the revs are rising, but then you suddenly decelerate, we'll get an unusual looking graph that's impossible to analyze. So it's important that we set these correctly. We want to set the minimum RPM above the stable idling point of the engine. So if the engine's running along in the dyno at say 2000 RPM, we'd probably want to set this up to, and this engine does, let's set it up to about, nudge it up to 2750. So that'll be our start RPM. So the engine will be idling at about 2000 RPM. When we're ready to test, we'll go wide open throttle, but it won't actually begin recording to 2750 RPM. That gives the engine a little bit of time to clear its throat after you've suddenly accelerated, and it gives it time to stabilize during the acceleration period. It gives us good data. The maximum RPM is really important also. This is where the dyno software ends the test. So you should set this very close to the maximum RPM that the dyno can achieve, the engine can achieve, so just short of it. So this engine will rev to about 11,500 maximum, so I'm going to set this to 11,000. So rather than nudge it up here, we'll just do a quick set. We can click on this and just write 11,000. So as soon as the software sees 11,000 RPM, it considers that to be the end of the test. That way, when the dyno is running down after you've backed off the throttle, it won't matter what you do because the data has been recorded. So that gives us plenty of time to stop the test without panicking to hit a button or anything. So very important that these two settings are correct. The other thing that we're going to do is, at the moment, in default settings, this RPM dial will be displaying the speed of the flywheel from the sensor that we mounted against it. Now really we prefer our graph to show engine RPM. So we need to tell the dyno for one turn of the flywheel, how many turns has the engine done. So this is a basic go-kart engine dyno. So we have a sprocket on the engine running to a larger sprocket mounted on the shaft that the flywheel is on. A pretty simple design. So to tell it that ratio, we come into this speed RPM screen. So in the case of ours, where we simply have an engine dyno with two sprockets, let's say the shaft sprocket was twice the size of the engine, we could just enter a ratio of 2. And that would mean that now the RPM dial will display true engine RPM. So let me just get the engine idling along there in the background. It's just a simulator we're using here. So I'm going to tell it a ratio of 2. So when I go enter, you'll notice that is now doubled, and we're using a ratio here of 2. So this dial now represents engine RPM. There are other ways of doing it. We'll probably do a short session on that alone. With an engine dyno, simple, we just do the gear ratio. but maybe we have a chassis dyno and we're riding a motorbike on it. So in an example like that, one quick way of getting the RPM without hooking directly to the engine, which we can also do, one quick way is to hold the engine at a target RPM and then press any of these ratio buttons. So as an example, let's say we were riding a motorbike on a dyno and we were in 4th gear. I've set this to say 4,000 RPM. So what I would do is I would ride the motorbike until the tacho on the motorbike reads 4,000. Let's say it was reading 4,000 there now. When I click it, it automatically learns the drive ratio and applies it. Okay, so we're not going to use that taut gear ratio that I just demonstrated. We'll go back to the U, the one that I manually entered. There we are, ratio of 2 to 1. So basically we're ready to do a test. So we'll get the engine idling below the minimum RPM. Now if you watch these colours change when it goes through the rev ranges. So all I need to do is when I'm ready is press start run, or I can press control spacebar as well as a shortcut. There's no hurry. It won't record until it sees the minimum RPM. So now I go full throttle. And once we get above 11,000, I can close my throttle off. There's no hurry to stop the run. It stopped recording when it's seen maximum RPM, 11,000. So now it will process the data. It's a funny looking trace because it's just an electric simulator that I have running here. But this is a preview of it. So if you're happy with that, we can save that to a file. We might call that new pipe, for example. Oops. Pipe. There we go. Saved. Now we can view that graph there. We'll do another test, so we'll go back to the dyno screen. Idling away there below the minimum. Start. Full throttle. Okay. Now this time we've already named it. Since we're going to do a series of tests, a quicker thing to do is just to press this, which is auto increment, save and close. I'm not pressing anything, so it will automatically in a minute close this screen down and show me the test that I just did. So there we are. Now you might want to see the test that you did originally. Well, we can load any test that we wish, so let's load up into this trace. The first test that we did, we called new pipe. You can see it's called the other one 001. It just automatically increments the name when I press that plus button. So I can preview it, I right click on it, it loads it. So the green trace was the first one that I did. So if we go and do another test now, go full throttle. There we are. Once again, I'll just use that quick function. Now it's called the new one, new pipe 002, etc. So it's just displaying the last run that I did compared to that other run that I loaded. So I'll just show you another little trick for rapid testing. At the moment, when we do a test, it's coming straight back to this graph screen. But we can actually turn that off quite easily. So first thing we might do is we might clear our graphs, which I can do with Shift Delete, or I can do it here. So basically wiping out all the previous graphs. They're still stored on a file, but they're just not visible now. We'll go to Setup Software, and if we go to Graph, we can get rid of this screen here, which will prevent it from previewing it every time that we do a run. Okay, so now when we do a test, start run, full throttle, when I save it now, just wait, it'll come straight back to this screen, ready to do another test. And we'll save that as well. Okay, so anytime that we wish, we can go back and view the graphs, and we can load up any that we wish to look at. But for very rapid testing, or another way of testing I should say, we can actually, I'll show you another little trick. In the software, the graph, we can make auto shift traces right. So in other words, now every time we do a run, it will keep the oldest run on the screen. So we'll do a series of runs fairly quickly, and then we'll come and have a look at that. Actually, I might turn this back on so we can show you this in action. So I'll do a test. You can see how quick and easy it is to do testing. You can do test after test. I'll just auto increment the name again. This will automatically close down this screen. So what will happen now is every time I do a test, it will just keep showing me over and over. That last one was actually hiding underneath the other one. They were so close to each other, even on this little simulator. You can turn them on and off, the visibility there. So I'll deliberately make this last test a little bit different with how I do the simulator. I'll do it a bit slower. Stop that. And there we go. So the last run being in red, and there's the other runs that I did. So in that mode, it just keeps marching the tests along the screen. So you can see 4, 5, 6, 7. So it always keeps the latest one and then gradually rejects the oldest one off the screen. So it always keeps the most recent 5 tests visible to analyze and compare. I can also, if I choose, I can lock one of them in, trace set 4, so that it always remains on the screen even as the others march off the screen as I do new testing. There is one other little trick that we can do to speed up testing as well that I'll show you while I'm in here. We can allocate shortcuts. So I can allocate the page down button to auto increment and save, and a page up keyboard stroke to maybe start stop. So now page up and page down on the keyboards is all I need to do to operate the dyno. The reason we chose page up and page down is you can buy one of those inexpensive page turners like you use for PowerPoint presentations, and control your testing basically by wireless handheld control. That just once again speeds up the testing. So there's a few simple options, but as you can see, the key thing is that we set sensible minimum run and maximum run RPMs, that you understand that the dyno does need to, if we're going to display engine RPM, it needs to know the ratio of the flywheel, where the sensor is, the dyno flywheel, to the engine RPM. And that's this ratio here. We can enter it here as we did manually. We can enter it manually in any of these. I demonstrated before how we taught it a ratio by holding the engine at a target RPM and then just pressing one of the buttons. So there are a number of options that we'll discuss in another session about, you know, possibilities to get RPM into the system. Once again, we could also test just in speed mode, as I mentioned before. Mainly used for chassis dynos for quick testing. Okay, since we've already got some data now loaded up and ready to show, I can demonstrate another great feature of the software. So we'll go back here to our graph screen. I'll clear all the graphs. Alright, so we'll load up a couple of new ones. So let's load up 4. So left click to preview it, right click to load it up. Load up trace set 2. Preview it, yep, that's the one. And here we might load up 6. So now we have 3 different test runs, all here to preview. So what we'll do at the moment, but we'll create a mathematical average of these. So we've done a few quick runs, now we wish to generate an average, so we'll go, all we need to do is go File, Merge Runs, Merge. So this will combine those 3 loaded up runs into a new one, which we'll call new pipe merged. Job done. Now I'll leave the source files, the original 3 there, just so you can see where the new one sits. Okay, so there's actually now been a new run created, which is this red run, which I can turn on and off, might make it a little bit more visible. That's actually an average of the other 3 runs. So if I actually highlight it in the data, that's now an average of the others. We can also see that if we look at the comments, these comments have automatically been generated to show the 3 runs that created that average. That also will show when we look at that particular files. It's also in the comments transferred through into the information field as well. So if we were going to actually probably hand this out to a customer, we want to clear away those other traces. So let's go View, and we'll clear the graphs. We want to keep that average one, and we'll get rid of the rest. There. So we're only left with that averaged test. Now, a little bit messy down here at the bottom, so we might trim that a little bit, because what we see on this screen is what gets printed out. So we can quite easily manipulate the graph and the scaling on it to get it visually how we would like it. There's a data trace here from a channel which we weren't using, so we can also clear that off. That's some trace visibility. And we'll clear off the other one as well. So now we're only left with power and torque of the merged run. So we're ready to print. File, print. We have a number of print options. Perhaps we'll do the detailed graph, which is a preview like so. Or we also have the summary. There's a number of print options that we can take advantage of. Okay, well that's a quick little overview of some of the software features. So hopefully you'll join me again and we'll explore a few more of the functions in our next little video. Thank you.